All right, the last part we're going to get into here, chapter 8, once again doing systems of equations, but now instead of actually graphing them as a line, we're going to do these algebraically. So this first kind is called substitution. That's where you substitute one into the other. Okay, so on page 468 in the text, if you got it, or sorry, 418 in the text, they give you this quick little diagram and they're showing a balance beam. Okay, so we've got two cones and a block, right? A cone, and a block. Two cones and a block. The weight should be 42 grams. Okay, so over here, they've got one cone is equal to three blocks. Block, 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 right? Okay, and then down here they've got another diagram. They've got 1, 2, 3, 4, 5, 6, 7 blocks, and that's equal to 42. So these are balance beams. So one is equal to the other, right? This is like an equal sign. These are balance beams, so one is equal to the other. So it says describe how diagram 2, this one, relates to diagram 1. Well, let's see. Diagram 1 has got these two different scales, but you notice that this one cone is equal to 3 blocks. So where you see one cone here, they turn that into 3 blocks. 1, 2, 3. One cone, turn that into 3 blocks. So 1, 2, 3, 4, 5, 6, 7. There it is. Oh yeah. So if you take the cones and you replace them with blocks, you get this. So these two together are diagram 2. So diagram 2 is the combination. So this is the combination of both of them in diagram 1. Both in diagram 1. Okay, now it says using diagram 2, what's the mass of one block? Well, hang on, 1, 2, 3, 4, 5, 6, 7 of them. So if 7 blocks is equal to 42, we know we can just divide by 7. In other words, you get one block is equal to 6 grams, right? And then it says, what's the mass of a cone? Oh, I don't know. But if you go up to here, it says a cone is equal to 3 blocks. So this was 6, 6, and 6. A cone should be 18. So one cone is equal to 18 grams. And then it says write an equation for the balance in diagram 1. So two cones in a block made 42. So I can write that as an equation. Two cones plus one block is equal to 42. What about the other one? Cone is equal to three blocks, right? One cone is equal to 3 blocks. And then it says write an equation for this. Well, this was 1, 2, 3, 4, 5, 7 blocks is 42 grams. 7 blocks is equal to 42. Really what we did is we took this and we replaced it into there, right? So 2 times 3 is 6, 6 and 1 is 7. That's what we got. And then we solved it. So this is the same idea. It says, like, here's a different system. What if you had 4 cones? Okay, cone, 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 cone. These are terrible cones. 9 cubes. Okay, I can't really do them as cubes. I'll do them as squares. There we go. I'll be lazy. 1, 2, yeah. So there we go. 9 cubes, or blocks, if you will, and 4 cones. That makes 161.50. Whoa, it's a lot of money. And then it says 1 cone is equal to 2.5 cubes. Okay, so 1 cone is 1 cube, 2 cubes, and then a half a cube, right? 2.5 cubes. So in other words, if I know that 1 cone is 2.5 cubes, I can replace 1, 2, 3, 4 of them. Oh yeah, 2.5, 2.5, 2.5, 2.5. So times 4. So 2.5 times 4 is going to give me 10, right? So 1, 2, 3, 4, 10, and 9 more. So 10 blocks. So in other words, 10 blocks plus 9 blocks is equal to 161.50. Hang on, so that's 19 blocks. 161.50. Divide by 19, divide by 19. I don't know what 161.50 divided by 19 is. Let me just plug it into my calculator. Here we go. 8.5. This is in dollars, right? Oh yeah, $8.5. So in other words, the blocks, or they call them the cubes, cost $8.5. Okay, so what about a cone? Well, remember, a cone is 2.5 cubes. So in other words, 2.5 times this. The cone is going to be 2.5 times 8.5. Whatever that is. I think it's going to be 16, 17. No, hang on. That's 21.25. 21.25. So we just did the exact same thing by taking one of these equations, turning it into this one. So what did we do? Okay, well, what were the steps that we did here? Let's see. The first thing we did was we replaced the cones with blocks. So replace cones with blocks. Okay. And then I divided in order to solve for the blocks. So divide to solve for blocks. Then once I figured out how much the blocks were, I used the result to solve for cones, right? And then I went and I solved for cones. Okay, so this is actually a substitution. When we do these in algebraic without cones and blocks and stuff like that, here's going to be our steps. First thing I'm going to do is I'm going to isolate one of the variables. So in other words, if it's a system with like x and y, you can use x or y, your choice. You can do either one. But I'm going to isolate one of the variables in one equation. You know what? Go for the easier equation. Go for the easiest one you can. Make your life easier. Then I'm going to take that and I'm going to substitute it into the other equation. It's always got to be the other equation. Because if you substitute it back into yourself, everything will disappear. That's useless. Okay, so let's substitute it into the other equation. Okay, then I'm going to solve for one of the variables. So it might be x, it might, excuse me, might be x, might be y. Once I've got one, then I'm going to solve for the other variable. Now, here's the only problem. Once I got one x and one y, they might ask me to check my answer. Now, when you check it, you got to check both the x and the y. You have to check with both equations. It's always got to be both because it's a system, right? So I have to check it with both equations. Now, when we were graphing these things, it was pretty obvious. It's the point where they cross. That's where they both work. So if we're not graphing it, we're not sure. So solve this system. I've got x, I got y. I've got x, I got y. So my first step is to isolate. So get either x all by itself or y by itself. I could move this over and divide everything by 3. I'd be making fractions. No. I could move this over and divide everything by 2, and I would be making fractions. No. Start with either. I'm going to start with the second equation. And I'm going to solve with y, this one. See, instead of isolating, instead of moving this over and this over, it becomes minus y. I'm going to move the y over to this way, and it becomes positive y is equal to 4x minus 22. Now, I could have moved over the x, but it's easier to move the y. Here's why. Because I don't have to divide by a number, right? I don't have to create fractions. If I was solving for x equals, I would have to divide everything by 4. I don't want to divide by 4, not 22. So here we go. Y is equal to this. So y is equal to 4x take away 22. I'm going to go to the other equation and plug it into there. So in other words, this has got to sub into the other equation. Now don't plug it back into here because it'll disappear. Watch what we get. 3x plus 2y. Now y is this thing, right? It's 4x minus 22. And they say that that's equal to 11. Right? So that's what I had there. This went into there. So, okay, it makes the equation a little bit bigger, but it's actually now just x. I can actually solve now. Let's try this. 3x plus 2 times 4. 8x minus 44 is 11. 3x, this is 11x minus 44 is equal to 11. I know I'm just going to add on the 44 to both sides and then divide by 11. I'm going to get x is equal to 5. Ta-da! Now, that's just x. I also have to figure out what y is. So once you figure out 1, okay, so here we isolated, we substituted in, I solved for one of the variables, I solved for the x, but now I need to solve for the other variable. I need to go back and plug it in to figure out where y is. Now I could plug it into here, 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 here. Remember this, what you did when you isolated the y? This is the smartest place to do it. Plug it right back into here. See? I've got y is equal to 4x minus 22. So 4 times x is 5, minus 22. So in other words, this is 20 minus 22. Y is equal to negative 2. Now, this is my answer. Now, I can either do it as an x and y point, right? 5 comma negative 2. That would be completely normal. Or you could also just say x is 5, y is negative 2, right? Because this is my two variables. Quite often, if it's x and y, we like giving it as a point. But if this was like, I don't know, p and m, whatever, it doesn't always have to. Usually it'll go alphabetical, but we don't know. Okay, how about this one? A tree nursery. They received 2 orders for cedar bushes and birch trees. Okay, so the first one is 40 bushes and 8 trees, totaling 1296. And then the second one is 25 bushes and 18 trees, and that's 1421. Okay, so what are we talking about? We're talking about bushes and trees. So first thing I'm going to do, I'm going to say B is the number of bushes. T is the number of trees. So I need to have 2 variables, done. I need 2 equations. So this is one equation right here. It says 40 bushes and 8 trees totaling. So that means it's equal to, the total is 1290. So there's my equation. 40b plus 8t is equal to 1296. That's one equation. Now let's do the second one. 25 bushes. Okay, 25 Bs and 18 trees plus 18T totals, so equals 1421. Okay. Step 1, isolate one of the variables. So either x or y. Oh, hang on, it's not x and y. Either solve for b equals or solve for t equals. What should we do here? I could start here. I could move this over and divide everything by 25. I'm going to get 18 25ths. That's not nice. I could move this over and divide by 18. I'd be 25 18ths. That's not nice. I mean, it'll work eventually, but not very well. Let's look for an easier way. Want to move over the 40 and I can divide by 8? Yeah, because if I divide all these by 8, right? That's actually 5. That's nice. 1296. I'm not sure what that is divided by. Okay, well let's do this. Let's isolate t right here. So 8t, oh, let's do that better. 8t is equal to minus 40 minus 4. So minus 40b plus 1296. Divide by 8, divide by 8, divide by 8. So I'm isolating t. T is equal to, so this is negative 5b plus, now 1296 divided by 8. What is 1296 divided by 8? That's 162. Yikes. But these are nice whole numbers. Okay, so this is going to plug into the other equation. Imagine, I don't want to graph this because I can't graph 1296 accurately. No way. However, this is a good one to do algebraically. So that is going to go into the t right there, right? Because t is equal to that, so that's where it's going. So this becomes what? 25b plus 18t. This is t. So it's minus 5b's minus 5b plus 162 equal to 1,421. Yikes, these are some big numbers. Okay, 25b, 18 times minus 5 is going to give me minus 90b. 18 times 12, 162. Okay, this is a very large number. This is 2,916. Yikes. Equal to 1421. Okay, so this is getting a little bit ugly, but at least there's no fractions, and I don't have to graph this. Okay, well, let's just continue on. 25 minus 90. I get minus 65b. Subtract off 2916 from both sides. So 1421 minus 2916 is going to give me negative 1,495. Yikes. Divide by negative 65. Divide by negative 65. I end up with b is equal to 23. Okay, that's a pretty nice number. That's probably not a coincidence. That's exactly 23. Okay, so is that the answer? No, hang on. That's only one of the, that's the bushes. So bushes are $23. Okay. Now I need to figure out what t is. I'm going to take my answer, either backtrack up to here, plug it in, you know what? Remember this one we isolated? This is the easiest one to do. Go back to here. Okay, so this, let's use an arrow. This is going to go back to here. So now my work is going to be t is equal to negative 5b, I know what b is, plus 162. So this is negative 115 plus 162. So in other words, 162, take away 115, I'm going to get 47. So trees are 47, bushes are 23. So yeah, I can actually put that up here. 47, pew, bushes are 23. So I did this one by actually solving for t is equal to, right? I have four options. I can either solve for t equals in the first equation, or I could have solved for b. Move this over and divide everything by 40. That would have been ugly, because I would have got 8 over 40, which is going to be a fifth. I'm creating fractions. Maybe I don't want to create fractions. I also could have started in the second equation, this one. I could have isolated 18, so move this over and divide everything by 18. I'm going to get 25 eighteenths. Yikes. Or I could have moved this over and divided by 25. I'm going to get 18 25ths. Yeah, those are not nice fractions. So let's not do that. You can do it 4 different ways. I can either solve for b or t in the first equation, or I can solve for b or t in the second equation. So usually one way is going to be way easier than the other. Okay, let's do one last try. It says, let's do example 2 by solving for the other variable in the other equation. What? Remember, we solved for t in the first equation. So let's go to this one and let's solve for b. Oh, that's going to be way harder. Well, let's see what we get. It should still work. What do we got? 40b plus 8t is equal to 1296. Okay, and over here I've got 25b's and 18. 25b plus 18t is 1421. So I'm not starting with the first one, I'm starting with the second equation. And I'm not solving for t, I'm solving for b. Okay, bring it back. Let's do this. Let's solve for b. In other words, minus 18t from both sides. So 25b is equal to, well, let's see, this is 1421 minus 18t. Okay. Divide by 25, divide by 25, divide by 25. What do we get? B is equal to 56.84 minus 0.72t. Not very nice numbers. I certainly don't want to do those as exact fractions. Let's just do them as decimals, because that's actually what they turned out to be. I'm going to plug that into the other equation. Now, this is what b is, right? So that's my b. It's going to plug into there. That's what b is. So here we go. I get 40b. This whole thing is b. 56.84 minus 0.72t plus 8t equal to 1290. Yikes, these are huge numbers. See why I didn't want to do it this way? These are ugly numbers. I'm going to multiply the 40 in. 40 times this. 2273.6. Yikes. Minus 28.8t plus 8t. Okay, 8t is equal to 1296. Now what? This is 2273.6 minus 20.8t equal to 1296. Okay, now what? Subtract off 2273.6 from both sides. That's 2273.6. Yikes, this is going to be huge. Negative 20.8t is equal to, what does it give me? Negative 977.6. Ugh, I'm almost there. Divide by negative 20.8, divide by negative 20.8. What do we get? We get t is equal to, by chance, it's exactly 47. Oh, see, we get the exact same answer. T is 47. It was just uglier numbers. You should work either way. Okay, now I want to go back and sub it into original. Okay, so let's sub into original. Now, if I really want to, this is the easiest one to backtrack to. Remember? I had b is equal to, I could solve it into there. And because I know what t is 47, plug it into there. So you can plug it into this one. This is the easiest one, but it should work in either one of these equations. It will. It'll work in either one. Now let's go with the first one. It should work in either one. Okay, so 40b's plus 8t's. Okay, so 40b's plus 8t's is equal to, it was 1296. Okay, I know that t is 47. So this is 8 times 47. 1296, 40b's. Okay, this is 40b plus 376 is 1296. Subtract off 376 from both sides. 40b is equal to 920. Oh, that's terrible. Divide both sides by 40, and here's what you get. You get b is equal to 23. Now, we did 47 and 23. See, 47 and 23. It's the same answer. So you can do it either way. You're never going to have to do this two different ways, right? But you can see that this way was way easier because the numbers are smaller. This way, oh, the numbers got hideous. They got ugly. It'll still work. But think about which is the easiest one. If I divide everything by the smaller number, or especially if you find an equation that's got no number, oh, that's fantastic. That's what you want. That way you don't have to create any numbers. Hang on, let's put it back in there. Okay, so a few things to remember. So you can solve for either variable in either equation. Yeah, so solve for either x or y in equation 1 or 2. It doesn't matter. You can do either one. They're both going to work in equation 1 or 2. But think about what's going to be easiest. So look for possibilities where the coefficient is 1. So look for coefficient of 1. Because that way you don't have to divide and there's no fractions. No fractions. Sometimes you can't avoid the fractions no matter what. But if you can, avoid them. And if it's not possible, so if not possible, then you know what? Probably the easiest thing to do is look for possibilities where you're going to get like a half. Possibilities of like 1/2 is an easy one because halves, 3 halves, 4 halves, those are pretty easy. Way better than thirds, right? Thirds are going to be repeating decimals. Look for possibilities of dividing by 2, so you get half, quarters, right? Maybe divide by 10, because 10 is actually nice because it turns into decimals, right? Quarters like 1/4, 3/4, 2/4, those aren't that bad. They're way nicer than sevenths. You do not want to do things with sevenths. Okay, so these are the questions I'm going to ask you to get started on page 424. So these ones all have to do with substituting x into y or y into x, your choice. So one into the other. And the last few are some word problems. Okay, so this is going to be our first part, and then our next part will be pretty much the end of this chapter. Alrighty, good luck with these.